Okay, our goal today is to be able to do implicit differentiation. You might wonder what implicit differentiation is. Well, we have explicit equations and we have implicit equations. So an explicit equation would be like y equals 2/3 x minus 1, or y equals sine of x, or y equals the square root of x squared minus 4. Those are implicit because we have solved implicitly for one variable, in this case, y. I'm sorry, explicitly for y. In this case, we have not solved explicitly for one variable. You can see x squared plus y squared equals 25. What graph does that make? It makes a circle with a radius of 5. Is that a function? No. So far, you've learned how to take derivatives of functions. What about things that are not functions? Look at the next one. Y plus x is equal to sine of xy. That looks very challenging. But the fact is, we can find those derivatives. In order to find those derivatives, we need to understand some terminology. This means the derivative of f, the function. This is terminology for the derivative with respect to x. And this one is with respect to x as well because x is identified as the variable. Study throughout history. So this says the derivative of y with respect to x. Okay? So I'm going to show you why it works out, and then I'll just tell you kind of the recipe for what you do every time. But this is the explanation part so you can hopefully understand. So just take the derivative. So I'm going to find the derivative of x squared plus y squared is equal to 36. Okay? And I've learned I can take the derivative of each piece. Okay? The derivative with respect to x of x squared plus the derivative with respect to x of y squared plus the derivative with respect to x of 36. Go get some brain food. Come on back smarter. We'll see you in a little bit. Lean in. Really try to absorb it, okay? What's the derivative of x squared? Notice how the power gets reduced by 1. Okay? The way that they explained this notation back in the day is the power gets reduced by 1. That x gets really absorbed right here. So what happened to your degree of x? It got absorbed right up top there. Plus, what do you think the derivative of y squared is? 2y. And the y gets absorbed up top there. And what do you think the derivative of 36 is? So you have e over dx times 0. Okay? Now, look at this. Dx over dx is 1 times 2x. Plus, well, now you don't have dx over dx, you have dy over dx. dy over dx is just a fancy way of writing y prime. It means the derivative of y with respect to x. This means y prime times 2y is equal to 0. Okay? Now, if we want to find the derivative, we're going to solve for y prime. How would you solve for y prime? So we got y prime times 2y is equal to negative 2x. So y prime is negative x over y. So instead of just having an x value in your derivative, you also have a y value. So you don't need to know just the x value of your point, but also the y value. Right? Now, before you go and say that that looks completely foreign to things we've seen before, just watch this. Um, what if I had 2x plus 4y was equal to 8? If you wanted to find that derivative, what you would do is you would solve for y, and you'd say 4y is equal to 2x plus, or negative 2x plus 8. You would divide by 4, and you would say y is equal to negative 1 half x plus 2, right? So what's y prime? Negative 1 half. Now, instead of just saying what's y prime, think about what's the derivative of y? 1 times y prime. What's the derivative of negative 1 half x? Negative 1 half. Watch as I do it implicitly and see how it makes a connection. D over dx. What's the derivative of 2x? 2. What's the derivative of 4y? 4. Attach a y prime because you have dy over dx. Equals, what's the derivative of 8? 0. Solve for y prime. 4y prime is equal to negative 2. Y prime is equal to negative 1 half. See how it works either way? When we've been taking the derivative of y equals negative 1 half x plus 2, we're actually taking the derivative of y. We're calling it y prime. It's 1 times y prime. So the rule is very simple. Anytime you take a derivative and it has a y in it, attach a y prime. If you don't understand why, then you got to rewatch what we just did. But in order to have success moving forward, just every time you take a derivative with a y, attach a y prime. You'll be good to go. So this one, I could put it in form of a parabola, or I could just take the derivative as is. What's the derivative of 3x squared? What's the derivative of negative 4y? Negative 4y prime equals 4. Solve for y prime. I get negative 4y prime is equal to 4 minus 6x. Divide by negative 4, y prime is negative 6x over negative 4 would make 3 halves x, and 4 over negative 4 makes negative 1. That's it. What's the derivative of y cubed? Y prime. Minus 5 plus equals 3. Oh no, I have 2 y primes. What should I do? You had it last year. Gather everything that has a y prime on one side, everything that doesn't on the, and then factor out a y prime. Okay. Yeah, but you're right. You said the factor piece, but right now it's not very good to factor out a y prime with the negative 5 sitting there. So you're on the right track. I just wanted to make sure we set it in the right order. So I factor out a y prime, and I get 3y squared plus 2. And I divide by 3y squared plus 2. That's my derivative. Not too bad, huh? You try letter C on your own. Let's go. Write your answer two different ways. Why are those equivalent? Top and bottom are different by a factor of, and -1 over -1 is 1. So as long as the top and the bottom are different by a factor of -1, you're fine. Is this what everybody got? Okay, so what's different about problem D? So if I have x times y, what do you think I need to do? That requires use of the product rule. So let's start back here. What's the derivative of 5y squared? Y prime. What's the derivative of 9x? Okay, now let's use the product rule here. It's really not that bad once you do it. What's the derivative of 3x? 3 times y plus 3x times what's the derivative of y? Y prime. No big deal. Emma? 3x was 3 times y left alone plus 3x times the derivative of y, which is y prime. Solve for y prime. I have 3x y prime. So f is 3x. So 3x, then the derivative of y is 1 times y prime. Y prime. Excellent. Good question. Derivative of 3x times y, left alone, not the derivative, left alone, plus 3x, left alone, times the derivative of y, y prime. You don't take the derivative of that. When you take the derivative of a y, attach y prime. I did not take the derivative of the y there. I left it alone. Right there. Okay. Yeah, I took the derivative of y, and it is a y prime. Yep. Okay. Okay. All right, got it. So, what do I do now? Take out a y prime, 3x minus 10y equal to -9 minus 3y. That's pretty good stuff, huh? You're going to be doing implicit differentiation on your next test. You'll also be doing on your final exam first semester, or first quarter, or second quarter, excuse me, and third quarter, and fourth quarter, and the AP exam. This is something that will not go away, okay? We'll practice implicit differentiation a lot. Back? I'm okay? Okay, so let's go back to the very first question we ever asked, which was, how do you find the equation for line tangent at a given point on a curve? So what two things do I need? And I need the slope. Well, how do I find the slope? Take the derivative. What's the derivative of x squared plus y squared? Or what's the derivative of x squared? Derivative of y squared? Good. Equals 0. Solve for y prime. So, what's the slope going to be? Okay, that's all right. All right, that's all right. Okay, that's all right. No, no, no. As long as we say our arithmetic kind of went to crap, that's fine. Like, I'm all right with that. All right, it's okay. It's all right. I was wondering what we were missing. Okay, yep. So the slope is 7 over negative 24, or negative 7 over 24, because you switch the x value, and then you just put the y value. So now we're going to write the equation for the line tangent. So I have y minus, or plus, 24 is equal to negative 7 over 24 times x plus 7. Or y plus 24 is equal to negative 7 over 24x minus be nice if 24 had a denominator 24, right? 24 times 24, 576, perfect square, right? 576 over 24, you guys know that. Y equals negative 7 over 24x, and I subtract that over negative 49 minus 576, negative 625 over 24. That's our equation for a line tangent. So, can I show you kind of a trick? Point on the line, right? 1, 1. In order to find slope, I take the derivative, right? So, what's the derivative of x squared? What do I have to do there? Product rule, derivative of 4x, 4 times y plus 4x times y prime minus 4y prime equals 0. So we're just trying to figure out y prime, right? Derivative of 2y squared is 4y prime. I have to use the product rule here. Derivative of 4x is 4 times y. Better. So I don't really need to solve for y prime necessarily. I could just plug in what? 1, 1. And we'll figure out what y prime is. So what goes in for x? And I get 2 plus 4 plus 4y prime minus 4y prime equals 0. Okay, what's 2 plus 4? 6 plus 4y prime minus 4y prime is equal to 0. So these cancel, don't they? So you get 6 is equal to 0. Is that possible? So what does that tell us about y prime? It does not exist. So the slope does not exist. So what kind of line does the slope not exist? A vertical line. Is that x equals or y equals? X equals. Just think if you had a circle and you're finding the derivative right here, that would be a situation. You would have a vertical line right there, right? Good stuff. Great job today. You guys are smart. Okay, I cut down the assignment for previous years, made it smaller. That's because I care about you and your learning. And I know although math is one of your favorite subjects, for some of you it isn't your ultimate favorite subject. Like it might be number 2 on the list. For others, it might be number 3. For others, it might be 576th on the list. Now, here's the deal, though. Last unit, we covered 3 sections. This unit, we cover 5. And that really has everything to do with just how quickly you can get the stuff done on the test. If I went 4 on 4, last test would be much longer, and this test would be shorter. So, we put trig, we put trig derivatives in, chain rule, and implicit differentiation, and those are really kind of one topic. I mean, they all kind of connect together. So, test is when? Friday. So get busy this weekend, and next Wednesday and Thursday won't be so bad.